All right, let's dive right into this explainer and trace the absolutely incredible 40-year journey of Anders Hejlsberg. We're talking about a legendary architect who has fundamentally transformed how millions of developers write code every single day. Seriously, if you have ever written a line of software, chances are you've touched something he built. We're going to look at his entire career, from the early days of microcomputers all the way up to the modern era of artificial intelligence. To really understand this evolution, we're following one relentless through line across 6 distinct eras: the fast developer loop, building a holistic platform, taming the JavaScript wild, the open source shift, rebuilding for maximum speed, and finally, the AI coding era. Through all of this, the core mission never changes. It's all about shortening that developer loop and removing friction.
Okay, era number 1, the fast developer loop. Let's travel back to the late 1970s and 80s. This was an era of 8-bit microcomputers and incredibly strict 64K memory limits. Back then, waiting an entire afternoon just for your code to compile was a universally hated developer experience. It was slow, it was frustrating, and it severely limited how fast you could iterate on a new idea. But Anders changed the game. Tracing his influence from the 80s all the way to the 2010s, this breakthrough really kicked off with Turbo Pascal's revolutionary ability to bypass the hard drive entirely and compile code immediately into memory. It gave developers this instant feedback loop that was virtually unheard of at the time. You hit run, and boom, it just ran. Now, what's really wild here is the impact of a simple business decision: $49.95. When Borland's founders proposed this ultra-aggressive price point for Turbo Pascal, Anders actually thought they were nuts. He literally thought they'd never make any money. But that low price, it pushed the software into the hands of a massive audience. It sold millions of copies. We're talking 3 to 4 orders of magnitude more than their competitors, and successfully democratized programming for an entire generation.
Moving on to era number 2, building a holistic platform. As systems scaled up, the era of the solo developer hacking away in their bedroom kind of ended. When Anders moved to Microsoft in late 1996, we saw a stark contrast between two competing philosophies. On one side, you had Sun's approach with Java: write once, run everywhere. But because Java insisted on working identically across every single operating system, it forced developers to use this rigid, least common denominator user interface. It just wasn't the best experience. On the flip side, we have the approach Anders and Microsoft took. Rather than settling, they designed C# and the .NET platform holistically. They integrated the language, the runtime, the garbage collector, and the class libraries all together to deliver a true best-of-breed experience with maximum native performance.
Zooming forward to our third era, taming the JavaScript wild. Thanks to HTML5 and powerful engines like Google's V8, developers were suddenly building massive, enterprise-scale applications right in the browser using JavaScript. But trying to scale a dynamic language without grown-up tooling? Oh, it was incredibly painful. I mean, teams at Microsoft, like the Outlook.com team, were writing their massive applications in C# and using a tool called ScriptSharp, literally just to translate it into JavaScript. They desperately needed type checking, refactoring, and statement completion just to manage hundreds of programmers. This bizarre workaround forced Anders to ask a pretty profound question. Is JavaScript really that broken? Is treating it like a compiled bytecode actually the best we can do?
Rather than starting entirely from scratch, Anders famously noted that the world needs another programming language like it needs another hole in the head. Think about it. Building a brand new language from scratch means you're starving for users for 5 to 10 years while you build debuggers, profilers, and IDE integrations. The much more pragmatic solution was to meet developers exactly where they already were. And they did that by creating TypeScript as a strict superset of JavaScript. They fixed what was fundamentally broken while letting developers keep using the rich ecosystem they already knew and loved. Next up, Era 4, the open source shift. Simply creating the right language wasn't enough. Microsoft had to fundamentally change its entire corporate culture. They faced a steep uphill battle to engage a notoriously skeptical JavaScript community, a community that would absolutely ignore a closed-source commercial Microsoft's product. Step 1 was fighting their own internal closed-source mentality. Step 2 was their initial open-source launch in 2012 on Microsoft's own platform, Codeplex. But let's be honest, it was basically a facade. They were just throwing code over the fence, and the result? Absolute crickets. Finally, Step 3, making the leap to GitHub in 2014. By going exactly where the action was, tracking issues in the open, and fully adopting community-driven pull requests, TypeScript adoption just exploded. It became a true win-win, where the community could literally watch the sausage being made.
Which brings us to section 5, rebuilding for maximum speed.
Now, massive success brings its own set of challenges, and TypeScript eventually hit a wall. Because the compiler was self-hosted, meaning it was written in single-threaded JavaScript, they were leaving incredible amounts of modern computing power sitting on the table. The solution? A dramatic one: rewriting the entire compiler in the Go programming language. By utilizing native code and shared memory concurrency, they unlocked an astonishing 10x performance gain. They took compilation times that were dragging on for minutes and crushed them down to mere seconds. When you see a 10x gain like that, you simply cannot ignore it.
And their deep commitment to the developer community dictated exactly how they executed this rewrite. Look, massive swaths of the community wanted them to rewrite it from scratch in a trendy language like Rust. But instead of doing a super risky rewrite from first principles, they picked Go because it allowed for garbage collection and cyclic data structures. They did a carbon copy, function by function port, intentionally keeping all the original compiler quirks and bugs. Why? To ensure that millions of existing projects wouldn't just randomly break when the new native compiler shipped. That is true dedication to your users.
Finally, we reach section 6, the AI coding era. We are looking to the horizon now, where AI is fundamentally changing the nature of programming. It's stepping in to eliminate the boring, uninteresting toil of maintaining massive code bases, things like porting legacy code or managing thousands of bug reports. But this brings up a rather counterintuitive truth. People constantly ask Anders to design the perfect programming language for AI, but actually, creating a brand new language optimized for AI is a terrible idea. Because an AI's ability to generate code is directly proportional to the volume of training data it's ingested, the absolute best language for AI is simply the one it has seen the most. Right now, that means JavaScript, Python, and TypeScript. A completely new language would be at a massive disadvantage out of the gate.
So, the day-to-day reality of coding is transforming into this era of AI developer supervision. The role of the developer is shifting, and it's shifting fast. Instead of manually typing out every single line of code in an IDE, we're increasingly going to be using agents and semantic services. The AI does the heavy lifting, executing huge refactors or writing out boilerplate, while the human programmer takes a step back to act as the director and supervisor, making sure the broader architecture is completely sound.
But this incredible shift leaves us with a profound challenge. I want to leave you with this final provocative thought to ponder. If AI completely replaces the need for junior programmers to write basic code, how do we ever get senior programmers? As AI narrows the base of the engineering pyramid, how exactly will the tech industry cultivate the next generation of architectural masters like Anders Hejlsberg? It's a fascinating question, and it's one the industry's absolutely going to have to solve as we move into this next era. Thanks for exploring this journey with me, and keep questioning the future of how we build.